Okay, so this next question, part B, problem 7.94, is how many kilojoules are absorbed when 326 grams of calcium hydroxide reacts? We're given this equation: calcium hydroxide reacts or decomposes to form calcium oxide and water. We're also given that the delta H is positive 65.3 kilojoules. So whenever you see the positive in front of it, that tells you that it's an endothermic reaction. And the positive also lets you know that it's going to be on the left side of the arrow, where the reactants go. If it was exothermic, it would be, just like in the last video, it would be on the right side of the arrow. It would be part of the products. Okay, so we're also, like I said, 326 grams of calcium hydroxide reacts. I went ahead and wrote the molecular mass. Yours might be a little bit different depending on what the book's periodic table has. But I got 74.0898 grams per mole. So first thing I'll do is rewrite my equation so I can get my mole ratio. So it'll be calcium hydroxide plus 65.3 kilojoules will give us calcium oxide solid plus H2O liquid. So now it's just back to your stoichiometry. First you need to turn this 326 grams into moles, and you'll do that using your molar mass. So 326 grams of calcium hydroxide times 74.0898 grams of calcium hydroxide for 1 mole of calcium hydroxide times, now we're going to go to our mole ratio. 1 mole of calcium hydroxide for 65.3 kilojoules. So 1 mole calcium hydroxide will give us 65.3 kilojoules. So from there, you might want to double check my algebra, but 326 divided by 74.089 times 65.3 will give us 287.324 blah 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 kilojoules. Putting that in the right sig figs will give us 287 kilojoules. As I said in the last video, if you have to type in kilojoules, you want to make sure that you put a lowercase k and a capital J. It should be your answer. Yeah, so these will cancel. These will cancel. All that you're left with, unit-wise, is kilojoules. That helps.